Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. Welcome to our presentation on the implementation of IoT system in optical fiber access network prototype at the Telecommunication Transmission Laboratory at Indonesia University of Education. My name is Desiana Fajar Wisdawati, and I'm presenting alongside my colleagues, that is Mr. Ahmad Fauzi, Ms. Endah Setiawati, and Muhammad Zikri Danwate. In today's session, we'll explore how integrating IoT with optical fiber technology that can enhance monitoring and control capabilities in a laboratory environment. This study is part of our ongoing efforts within the telecommunication system program study to bridge the gap between IoT advancement and high-speed data network. Introduction. The rapid increase in internet traffic from services like triple play and cloud solution has created business opportunities for telecom operators, allowing them to offer value-added services. Several studies have contributed to developing optical fiber access network simulation systems. This includes one fiber optic cable network train kit designed by Stephen Daniel and others for fiber optic installation training aiming for competency certification. QNQ method and Metro Ethernet network, conducted by P. Pangestu and others. This research focused on using VLAN QNQ with gigabyte capable passive optical network technology to address VLAN ID limitation at Beta Telkom Indonesia. Electrical installation kit for learning media, developed by A. Monitasari and others for practical learning and electrical installations involving kit design, microcontroller, programming, and component testing. This research developed a prototype fiber optic network, a transmission lab featuring open source software, various simulation scenarios, and online learning integration. It aims to support UN Sustainable Development Goals, specifically SDG 4 on quality education, by changing telecommunications, education, and training students in fiber optic network skills. So what is the IoT? The Internet of Things, or IoT, is a network or connected device that communicate and share data online, enabling real-time monitoring, automation, and control across various sectors. So the IoT, or sense plug, will collect with fiber to the home prototype. So energy efficiency has become a global priority due to rising energy demands and environmental impacts. Traditional electricity methods still common in Indonesia, like real-time monitoring, limiting users' ability to manage energy effectively and often leading to waste. The study presents the Sense Plug, systematic energy monitoring and smart efficiency plug, an IoT-enabled device integrated with a fiber to the home network, developed for the transmission lab at the Indonesia University of Education in Purwakarta. SenseFlag offers real-time monitoring, anomaly detection, and remote control of electricity use, supporting both energy efficiency and the smart lab concept. The system promotes sustainable energy management while contributing to IoT research in energy efficiency. SensePlug demonstrates the potential of IoT in advancing smarter and more sustainable energy solutions. The next page is about research methodology. There is 6 steps. The first one is about concept, and then system design, detail design, manufacturing, test, and the last one is shape. Research object characteristic. The object of this research is network construction in optical fiber networks, which can also be described based on the main tools and materials needed in the form of software and hardware. The software used is for simulating network usage in the form of an IoT-based system, namely IoT Cloud. Then for the hardware such as optical light source, optical fiber backcord, optical distribution frame or ODF, optical distribution cabinet or ODC, optical distribution point ODP, optical rosette, media converter, and optical power meter or OPM. Data collection techniques. Data collection of this research consists of data on the result of measuring power loss in the system, as well as data on the result of measuring the IoT system test on electrical power measurement. In measuring power loss in the system using optical light source or OLS as a light source and optical power meter OPM as a measuring instrument. Data analysis techniques. And formula number 1 is a formula that can be used to calculate the attenuation value received on the device. This formula indicates that resultant power is calculated by subtracting the product efficiency loss and the total time from initial power of reference power. And also, we can obtain accuracy of IoT system that integrated to prototype of fiber to the home. This formula is used to calculate the error percentage of the IoT system. And there is formula for accuracy. The accuracy is calculated by subtracting the error percentage from 100%. So this is research methodology. Okay, here's the implementation of the research methodology. In real life, there is the pictures. There's OLT, ODC, ODP, and ONT. So this is the workflow of the whole system. The IoT or sense plug will connect to fiber to the home access point. So the IoT will connect to internet and can communicate with IoT cloud, and then sense plug will read the value that the electronic appliance use. Data result. Table 1 is about loss measurement between optical line terminal OLT to reset. In the table 2, it's about comparison of measurement result for IoT system and calculation with varying power loads. Inward. So there is a 10 appliance and combination of loads with varying loads. And here's the discussion. In the table 1, which shows the loss measurement between the optical line terminal or LT and reset for two different core connection. Core connection 1, for the first core connection, the reserve power is measurement at negative 6.48 decibel milliwatt, while the transmitter power from the OLT is negative 10.10 decibel milliwatt. The calculated loss, which represents the difference between transmitted and received power, is 3.62 decibel. This value of loss indicates the attenuation experience in optical fiber link between the OLT and the reset for this specific core connection. And there is core connection 2. For the second core connection, the received power is negative 6.86 decibel milliwatt with a transmitted power of negative 10.54 decibel milliwatt. The resulting loss is 3.68 decibel, showing a slightly higher attenuation compared to core connection 1. This measurement reflects optical power loss encountered in each core connection, with both connection experience losses around 3.6 up to 3.7 decibel. Such attenuation can influence by factors like fiber quality, connector integrity, and any bends or splice in the fiber path. Maintaining these loss values within acceptable limits is crucial to ensure signal integrity and reliable performance of the optical network. In a practical application, these values can help determine if additional signal implication or improve fiber quality is necessary to optimize transmission efficiency. And the table 2 shows the comparison between calculated power using the formula power and the sense plug. Measurement shows that the system achieves high accuracy across varying power loads. Each appliance active power loads was calculated and measured with the resulting error percentage remaining low, average 0.48%, indicating minimal deviation between calculated and measurement values. The accuracy of sense plug measurement range from 90.8% to 100%, averaging at 99.52%. This high level of accuracy highlights the reliability of the sense plug in monitoring power loads for various appliances, validating its effectiveness for real-time energy management. In calculation, the optical power loss measurement between the OLT and reset show consistent attenuation level of around 3.6 up to 3.7 decibel across both core connection. These values fall within acceptable limits for short-distance connection, but highlight the need for careful fiber handling and connection quality to ensure reliability performance. Regular monitor of loss levels is essential to maintain efficiency data transmission in optical networks. The measurement result of sense plug showed that the average error for power is 0.48 It also indicates that sensors show optimal performance under a wide range of load conditions, ensuring measurement accuracy and consistency across the entire power range. That's all for us. Thank you very much for your attention. Goodbye. Assalamualaikum warahmatullahi wabarakatuh.